So today we are going to do applications of differentiation. The 5 applications you all have already known. Okay, there's only one extra thing that we are going to do, which is called the graph of dy dx. Okay, so first, tangent and normal. So remember, the first thing is write down the curve, the tangent, and the normal. They will always meet at x. X equals to k or something. So for example, yeah, this is a curve. There, this is a tangent. Okay, what can you tell me about normal? A normal is always perpendicular to a tangent. Then this is a normal. They will always meet at the same point. Can you see? They will always meet at the same point. Okay, so to find the gradient of tangent, we need to find dy dx first. So what is a gradient function? A gradient function means it is in terms of x. To find the gradient of tangent, you need to always sub in the value of x into the dy dx. And the gradient of normal is equals to the negative reciprocal of gradient of tangent. This we already know. So for example, if let's say the grade, so you can write things like m tangent or equals to 3/4. Then m normal is equals to what, Josh? You know what? Negative reciprocal, you know what? Negative 4/3. Okay, just flip it over. To find the equation of tangent or normal, we always need a pair of coordinates, which is the x comma y. You will need the x and the y. Sometimes the question doesn't give you the y. You must sub the x into the equation to find the y. Or sometimes question only give you y. You must sub in the y to find the x. Or sometimes it's parametric. You need to sub the x and the y to find the t. Okay, then apply y equal mx plus c or y minus y1 equals to m bracket x minus x1. Okay, so the first page is actually just a summary of the things. Some things if you can remember, good for you. Some things if you cannot remember later, I will go through more in detail. Increasing function means a graph that is always going upwards. Draw like that, going upwards. That means if a graph that is always going upwards, right, the gradient is always positive. So that's why the dy dx greater than 0. Okay, and the graph that is going downwards, or dy dx less than 0. Increasing gradient, decreasing gradient is lesser tested at H2. Is last time when we are doing O levels, when we're doing secondary school, we always have this. Okay, but when it comes out, then we talk about it. Okay, dy dx is equals to dy dt divided by dx dt. Again, in secondary school, there are things like this, or dA dt. Write down for me. Equals to, oh, you need dA dr multiplied by dr dt. Okay, what does dA dt means? The rate of change of area, well done. Or of area, very good. Okay, then in this case, this one is for rate of change of radius. You know what I mean? Yeah. Okay, so y can be replaced by v or a, or x can be replaced by height or radius. Okay, when a rate is decreasing, put a star down there. Remember to include a negative sign. When do you know something is decreasing? The volume gets lesser, the area gets smaller. Okay, that is when you do decreasing. And of course, so differentiation, there will be about 2 to 3 questions in your exam, in your final exam. Okay, that will come out. Yeah, stationary point 100% come out. 100% means dy dx equals to 0. How many types of stationary point are there? 3. What are the 3, Josh? Maximum, minimum point, and then point of inflection. Yes, very good. Okay, later I will show you again what the last point of inflection means. So I already say down there are three stationary point: maximum, minimum, or point of inflection. We usually do the second derivative test to check whether is it maximum or minimum. Okay, always use the second derivative test if the thing is easy to differentiate. Okay, sometimes you may not be able to be so lucky because when you do the second derivative test equals to 0, right? There's no conclusion. Then if there's no conclusion, then how? Must use the first derivative test. Okay, what is the first derivative test? I purposely put it down here. Okay, if dy dx is equals to, this is dy dx given to you already. All right, so for always write down for stationary point. And Mr. Ivan has always done this when I was a student. Why I can get A for all my math is because I will always write the things that matters to the marker. Then the marker had no reason to mark me down. Okay, for stationary point, dy dx equals to 0, which means 2x minus 2 equals to 0, x equals to 5. Okay, now how do I use the first derivative test? The first derivative test, always draw a, I think 4 line, 4/2. Yeah. Okay. So first, this guy is the x. Over here is the dy dx. Over here is the tangent. Okay. When dy dx equals to 0, Isaac, what is your x value? What is 1? So the 1 you write in the middle. Okay. What is a value smaller than 1? You put 1 minus. Do not put 0.9. Even though maybe in your mind, yes, you think that okay, I'm going to use 0.9. Understand not? Over here put 1 plus, which over here maybe you think yes 1.1. Okay. Now you sub. Okay. So in the middle, right? When dy dx equals to 1, sorry, when x is equals to 1, Sean, what is the dy dx value? 0. The center part is always 1. The x value 0 and flat. Because when dy dx equals 0 means the gradient is horizontal. Understand? Okay. 1 minus, now you sub in 0.9 right into your dy dx. So look here, this is your dy dx. Yeah. You sub in 0.9 into your dy dx. Or 2 times of 0.9 minus 2. You get positive or negative, Vanessa? Negative. You don't even need to know what is the value. You can use by logical. 2 times of 0.9, 1.8 minus 2, negative. The tangent is going downwards. 1 plus 2 times of 1.1. You can use calculator for you, for weaker guys. 2 times of 1.1, 20 times minus 2, you get positive, and then you go upwards. In this case, what point is this, Yingshuan? Maximum or minimum? Minimum. So x equals to 1 gives a minimum point. This is called the first derivative test. I know a lot of you forgot how to do. Okay, can? Yeah, so the stationary point will always come together with what? Maxima, minima problem. Use the information from the question to form one equation. Okay? The one that you want to remove is always the subject. Okay, use similar triangle when needed. You cannot differentiate two variables on the right side. So for example, v equals to pi r square h. Can you see r is a variable, h is a variable? Can you differentiate two variables? You cannot. You have to use the information to remove either r or h. So the one that you want to remove, right? So for example, if you write down, if you want to remove r, then you make r the subject. Just write down first. Later, maybe when we do, you will understand. Okay, you are expected to leave your answer in exact form and not in 3SF form. You only leave in 3SF when the question asks you to do so. Okay, Ken, if you have two answers, you must justify which answer gives you the maximum or minimum, or whichever x is a greater than 0. Okay, so something like this. If v is equals to x cubed plus 2x plus 1, when I differentiate this, Yingshuan, tell me what is the notation? Come on, dv dx equals to, tell me what is the answer on the right side? 3x squared plus 2. Understand or not? Okay, then again, then you write for stationary point. Okay, dv over dx equals 0. So you have 3x squared plus 2 equals to 0. Okay, yeah. So x squared equals to negative 2 over 3. Is it possible? Is it possible? Not possible, right? Write down NA. Therefore, there is no stationary point of V. Sometimes we use this to justify. Understand? Okay. Okay, so the first front part is to recap the 5 major applications of differentiation that we have done in secondary school. So you go to the next part. Yeah. So can remember anything that is at the top, f prime a. A means what? I sub x equals to a inside. Okay, so this is the graph. This is called the increasing, decreasing function. Yeah, can you see that anything that is over here is going upwards, right? So Isaac, this is increasing or decreasing? Increasing. Anything that is over here going downwards, right? This is increasing or decreasing? Decreasing, just simple like that. Okay, but what is the concept? Dy dx greater than 0. Over here, can see the dy dx is greater than 0 because all the tangents are going upwards. And this part is all the tangents, they are going downwards. Okay, and so on and so forth. Okay, go to the next page. I want to tell you is that, right, when we do the first derivative test, right, for example, just look here and understand, just look here and understand. So let's say, for example, okay, your dy dx is a quadratic. Let's say x squared minus x minus 6. Okay, dy dx equals, okay, so again, always remember to all for stationary point. Just look here and understand what I'm trying to tell you all. For stationary point, dy dx equals to 0. Don't have to copy down, equals to 0. So this means x squared minus x minus 6 equals to 0, right? Then this means x minus 3x plus 2 equals to 0, right? Yeah. This means that x equals to -2 or x equals to 3, right? Obviously, for this guy, right, is it easy to do the second derivative? Yes or no? Yes, right. Then it's easy. Then you go and do second derivative. Yeah. But do you think question like that will come out? No, right? Sometimes it will be implicit differentiation, like what we did last week. But what I want to tell you is that if you have two coordinates, right, and you want to find the nature, right, when you go and do the first derivative test, right, you can do this. Look here. Look here. Look here. So remember, the first row is always called the x. The second row is the dy dx, right? The third row is called the tangent. Okay. Now, when I have 2 here, sorry, the smaller one, this guy will be -2. This guy will be -2 minus. This guy will be -2 plus. Okay. What is a value that's lesser than -2, Isaac? Too far away. Yeah, too far away. Okay, you all know why we don't use -3 or not? Because there might be another stationary point that might be there. So don't use anything that's too far away. -2.1, and then this one is -1.9. Understand or not? But what I want to tell you is that when you have two stationary points like that, right, you can combine the two into one table. You don't have to do two tables for this because a 2 plus is considered a 3 minus. Understand what I'm saying? Not very common lah. A -1.9 is considered a 3 minus. Smaller than. Yeah, it is very far. But because you at this point, right, these are the two values, right, that is within your range, right, that has the dy dx equals to 0, you know what I mean? Okay, so this part is 3, and then this part is 3 plus. This is what it meant by, something like over here. That means the A plus and the B minus, right, can actually combine together. Right? But of course, if you want to play safe, you draw two tables for -2 and 3, right? It's totally fine. It's totally fine. Okay, it's okay. Say again. Yeah, there will not be because your quadratic equation gives you the two roots that is between the -2 and 3. But anything on the most extreme left and the right, I don't know, because in this case it's quadratic, we already know there's only two roots, man. Sometimes, how about you do z x to the power of 4, there will be 4 roots, you know what I mean? Yeah, okay, that may be far away. Okay, can? So the graph of derivative, turn to the next page. Okay, graph of dy dx is the new thing that is important. Write down new. Okay, I want to tell you 3 steps that is simple. Number 1, any stationary point, right, will become x-intercept. Write down first. Okay, any stationary point, right, will become, okay. Then number 2, look at the tangent of the curve. Okay, so what I want to tell you is that, right, just apply these two things. So you look here. Draw an N-shaped curve. Draw an N-shaped curve now. Okay, I want you to mark out like 3 points here. Yeah, like this. Mark out 3 points here. Okay, the one that is more steep, right? Can you see this one more steep, less steep, and lesser steep? Okay, always label this as like 5. Then this one become a 4. This one become a 3. Understand? You do this step. Oh, you will not screw up. Okay, can you see? The gradient of 5, the more steep gradient is bigger value, right? Yeah. Then whenever it's going, if it's going downwards. Tell me what is the value of this, Josh? This one. A -3, bro. Understand? This one. Negative 2 or negative 4, Yingxuan. The next one, negative 2 or negative 4. Negative 4, and then this one negative 5. Understand or not? And I always do this, and I always use this. Then you will know how to draw the dy dx curve. Okay? Can? So first, stationary point will become x-intercept. Then next, look at the tangent of the curve. The rest, okay, is the point of inflection will become the turning point. Okay, the point of inflection will, later when we will do, right, don't need to memorize. If you know how to do these first two, right, then it's okay already. Okay, and actually there's a third step. Is vertical asymptote, still vertical asymptote. Put the star down here. Okay, vertical asymptote still become vertical asymptote. A y equals to b is a what kind of line? It's a horizontal line, right? Okay, so you draw a horizontal line here and you tell me the gradient of a horizontal line, Janessa, is equals to 0. Understand? So a horizontal asymptote will always become y equals to 0. Because the gradient of a horizontal asymptote is 0. Okay, understand? So a horizontal asymptote will always become y equals to 0. Okay? Can? An oblique asymptote, look at here, y equal mx plus c, right? What is the gradient of y equals to mx plus c, Sean? Yeah, so the gradient equals to m. So f prime x will tend to m. That means there is a y equals to m horizontal asymptote. So these are the 3 steps. Number 1, stationary point become x-intercept. Number 2, look at the tangent of the curve. Number 3, you must know what your asymptote become. Okay, asymptote will be at the start there. Always just think f prime x means gradient. Can already. Okay, gradient okay, always means gradient okay. So you look at this. Okay, look at this curve Okay, so look at the first curve. Number 1, where are the stationary point? Yingxuan, tell me. X equals to what? -1. So you label -1 here. Understand or not? So settle the x-intercept. So number 1, always settle the x-intercept. How? Stationary point becomes x-intercept. This will become 1. Okay? And I teach you how I do number 2. I teach you how I do number 2. Look here. What do you label as these 3 numbers over here? Josh, what do I label as these 3 numbers here over here? 5, 4, 3. Understand or not? Okay. Then after that, it goes down, right? You see, this one become -3. This one become -4. But instead of going more steep, right? Did it become more steep or less steep? Less steep. So this line over here will become -5 or -3. -3. Very good. Can see, ma? Always draw the tangent to the curve. Then after that, you realize that, okay, 5 means positive or negative? Positive, right? From positive. I increase or decrease? Decrease. Go down. Hit here. Hit the -4. Because you see, it will become negative over here. It will become. Anyway, once you pass the x-intercept, you must go to the bottom. Once you pass the x-intercept, you must go to the bottom. Most of the time, 90% of the time, there are some instances where it will become positive. Point of inflection. It means point of, actually, usually only point of inflection will go back up again. Okay, later we'll see whether I got some point of inflection questions. Then you see, yeah. Now, -3 means it increased, right? I know that I need to hit this x-intercept, right? So you said, everything just very logical. Go back up. Finish already. So you realize you only need to do 2 things. Number 1, settle the x-intercept. Number 2, you must know the value of the tangent. Okay, this 5, 4, 3, right, is my way of teaching you. Understand? It's my way of teaching you. Can? How do you label the graph? Look here. The y this is called the dy dx against x graph. Where? Negative, bro. Yeah. So over here is -3. Over here is -4. It goes back to -3. Can see not? Here is -3. It goes here to -4. Imagine the number is imaginary, is not exact values. It's just values to guide you to know how the shape goes. After that, it goes to -3. So it goes to go up or go down. Go up, ma. Then you see, it needs to go back here to -3. Then it goes up again. Anyway, because the x-intercept is there, right? It's quite obvious you need to hit back, right? Yeah, the value because the tangents. What is the meaning of these tangents? It's the dy dx. The gradient of tangent means dy dx, right? So now you need to draw the dy dx curve, right? I'm converting the gradient of tangent into values so that I know how does the shape look like. This is my way of teaching you. May not be at 0. Because over here, right, it is the point where it goes to the most steep already, right? Then it become more gentle, right? So that's why it goes up. Can see not? At this negative point, right? At this part of the origin, it becomes the most steep already. Then it starts to go more gentle. So that's why it will go up. That's not really a point of inflection. Yeah, that's not really a point of inflection. Huh? The point of inflection, it feels more like this. That you see, because at this point, right, the gradient is not 0. That's not a point of inflection. Yeah. But can you see, point of inflection is like that, where the gradient has to be 0 at that point. You know what I mean? Yeah. But in a way, it does. When there's you see the gradient change from going to be more steep than less steep, right? Yeah. Then you become like that. Okay. Anyway, this is just the first example you all do slowly. You know, you will do a few examples, and then by the time exam comes, you all forget everything already. Okay. Number 1. First thing, what do you do? Sean, tell me. Stationary point become x-intercept. So where is the x-intercept? 2/3, right? Yeah, the y don't care about it. The y don't care about it. Okay. Next thing, vertical asymptote. Any change with vertical asymptote? No. Okay, so vertical asymptote still remain dot 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 dot. Over here. Okay, understand? Now, can you see the horizontal? What is this horizontal? See y equals to 2, right? What is the asymptote of? What is the gradient of y equals to 2, Janessa? 0. So there is a horizontal asymptote that is over here. You all try to highlight yourself. Okay, can? Yeah. Hey, this part, right, that follows like that, right, will always follow the same suit. Why? Again, see, the first value, what do you think you write, Janessa? Maybe 3, then 4, then 5, right? So it goes increasing, right? Yeah. So that's why this one, right, will follow like something like this. Technically, 3 is not the best, maybe 1 is better because it's very close to 0 already, man. Can you see it's very close to 0 already? Yeah. So maybe you write 1, 2, 3 is better. Then you will go all the way up to. Can you see? By the time it goes up, right, this is close to infinity already. The gradient of this becomes close to infinity. That's why it will go all the way up to the sky. Understand? Don't be tricked by where the graph is. Look here. The graph is at the negative part. Whatever you do in your dy dx doesn't care of where the hell the graph is in the first part. The only thing we care about is the gradient. What number you put here, Janessa? 5. Yeah. 4, 3. Then this part becomes 0, right? You realize that 5, 4, 3 is positive or negative? Positive, right? So where do you think it will come from? It will come from, yeah, very high. And then you will hit here because you want it to hit here. Okay? Can see? So after it crosses the turning point, which is your x-intercept. Now it starts to go down. They said again, like that, right? Then it becomes, sorry. It becomes like that. But after that, it becomes less steep again. Can you see it? Less steep, steep, less steep. Okay? So what does this mean? Basically your ending point. So look here. Your ending point, right, is very important. This gradient is 0 plus or 0 minus? 0. But it's going downwards, right? So it's 0 minus. Or even if you put -1, it's also okay. Okay, you put -1, it's also okay. Can you see? So I know that because there's, can you see there's an asymptote here? I will have to go under and then go back here. Close to the y equals to 0, but can you see? Because number one, there's an intercept here, right? It means the graph must go down, right? But towards the end, because I know that my, can you see it becomes less steep, steep, less steep again. Yeah. So something like over here is like, oh, imagine you think of it as this one is -1, -2, or rather -1, -2. It start to become -1 again. Then over here it start to become -0.1, something like that. So that's where you know that it must go towards the asymptote. And that is the hardest part of, okay, that is the hardest part of the dy dx graph. But if you listen to me, number one, Mr. Ivan say stationary point make it become, Yingxuan, stationary point become x-intercept lah. You all know why? Because look here, you all know why stationary point become x-intercept? Because stationary point means dy dx equals to 0, right? Yeah. So this means that the y of y equals to 0 for this graph. So that's why it's a x. That's why it's an x-intercept. No, like it's less steep, it's less steep. Because at the, okay, yes, it's less steep, but it's supposed to be less steep. Maybe where I draw is not the best. Because at the, you tell me at the top, the gradient is what? After 0 must go to what first? 1 first, yeah, -1. Then it goes to -2 first, then it starts to go back to -1. You know what I mean? Because after 0, you cannot immediately jump to -2, you must go to -1 first. Understand? And then don't confuse this with the reciprocal curve, which a lot of you forgot already. 1 over fx curve, which a lot of you forgot already, right? Not? Yeah. Okay, anyway, these three curves are some of my weakest also when I was a student. 1 over fx curve, modulus curve, as well as derivative curve. Okay, the graph y equals to fx is shown above. A and B has the point, this point is 3, -2. This point here is 4, 0. This point here is 0, 0. Okay, first thing, do what? Josh, tell me. Yeah, so what are the two x-intercept? Very good. So just mark, don't mark cross, just mark something like this here and here. Okay, so label this as f prime x. F prime x and dy dx is the same. Yeah. Okay. Second, Stern, x equals to 6. This asymptote. Anything? Any change?
No.
No change. So just label the x equals to 6 over here. Okay, and Stern, x equals to y equals to -2. This becomes what?
Y equals 0.
Y equals to 0. So do a dotted line at y equals to 0. Yeah, 0 and 3. Oh, 4. Oh, sorry. Yeah. Hey, my mistake. Yeah, sorry. So Josh, it's not 0. The stationary point become the x-intercept, not the x-intercept become the x-intercept. So stationary point. So this is the only x-intercept. Okay, so the x-intercept, you know, in a way it doesn't matter. The x-intercept here doesn't matter anymore. Okay, so always draw 3 tangents. Can see 5, -5, -4, -3. Okay, then after that it pass here. 3, 4, 5. Okay, can? Yeah. So you know that this last part, right, must tend towards this asymptote. So this part I will settle first. Oh, I know I need to cut here. Right, 3, 4, 5. Can you see 3, 4, 5? Okay, and because it must go towards infinity, right? It cannot. So your thing is, you must think under the graph, right? How is the shape that you are supposed to draw? Okay, are we going to draw A this way or B this way? A or B? Sean, the one that's before the tree. This part I'm going to draw before the tree. Think you want it to go towards the infinity. A or B? A. A, correct. Because you see the gradient is -5, right? You want it to go to negative infinity. So that's why you need to draw it. Understand? It will tend towards something. Right? If you go this way, it will tend towards something. It will tend towards something. You see? Yeah. It will tend towards something. Okay. And then actually the last part here, the previous, can you see this kind? This kind, right? Yeah, I never go and do this. Right? 5, 4, 3, close to 0, right? So it's positive, right? Positive means on top of the graph or below the graph? 5, yeah, on top. So it should be, yes, it should be this way. Yes, you're right. Because it's 5, 4, 3 is decreasing. This one a bit tricky. You will realize that it's get -1, -2, then it like become -3, but towards the end, it will actually become, so it will become like -4, but after that it will become -3 again, because when you want to go to 0, right? Yeah. So it will go down, but you know that you need to cut. This part is very close to 0. The first part, because it feels like there's a asymptote there. Can you see? It feels like there's a, so over here, right? It's like -1, then it becomes like -2, then it becomes like -5. But after that, you must cut leh. So you know that it's going downwards already, right? Right or not? But how to cut it back? Turning point, lor. Yeah. Can see? Go up, hit, just go towards this asymptote can already. X equals to 1 is a vertical asymptote, it will still remain as a vertical asymptote. -1 is the turning point. The turning point becomes x-intercept. Understand? Yeah. So things can go down. But after that, in order for it to be stationary, but you know that the x-intercept is there, right? So you must curve back upwards. So you know that it started at very close to 0, right? Or not, Yishan? This started at very close. The gradient is very gentle, right, at the start. Then it becomes what? Yeah, it becomes steep. Then after that, it becomes what? You need to hit here, right? Then how? If you need to hit 2, then how? Turn off. Again, then you go. Yeah. Can see? Can you go towards this asymptote? Then the other part, be careful. Don't just follow. It's always like the opposite because of the gradient. Show me.
The y-intercept doesn't have anything.
Doesn't have anything. You can't find. Increasing. Okay, so you will increase to a certain value. I don't know, and you start to go down. Then there's actually a vertical asymptote that's down here. And then the other side, it will be negative infinity. As long as you start to go up, right? But you realize there's an x-intercept there, then you must come. It's like, yeah, you can see this part. My gradient, right, is like, oh, -1, -2, -3, but there's a turning point. So when, sorry, not -1, -2. Yeah, it should be 1, 2, 3. Basically, I'm starting to go up. But hey, I got a intersection, right? You have to curve down. Then follow the vertical asymptote. Just very simple. Then this part, -5, -4, -3, close to 0. You just go.
But then after the 1, isn't it still positive?
Think of the tangent. This one going downwards, bro. Yeah, just think of the tangent. Don't care how, yeah, what is the value of the graph. Think of the tangent. Okay? Because there's not always there. Because in this case, the graph tends towards here, right? Or y equals 0. Because of this line, a horizontal asymptote will become what is the gradient of y equal to? That's why the asymptote is y equals. The horizontal asymptote will have a y equals 0 asymptote. Okay, basically not y equals 0, you know. Basically, this is called dy dx equals 0. Hmm. The question tells you, okay, so look here. The sketch, just look up. The sketch shows you the f prime x and the modulus fx. Okay, so okay, what I want to tell you is that this part, don't scared first. Don't scare about this part first. Don't scare about this part first. Maybe, okay. So, Shen, can you tell me what is the meaning of f prime x?
dy dx.
Which is called the gradient of the tangent, right? Yeah. Okay, the reverse is a bit hard to understand. Don't be fooled by whether the graph is going up or going down. Just make sure you know that the graph, right, is in the positive or the negative. So basically this one, I know that here, okay, over here, there's a turning point. Can you see turning point in the original graph? Because this, strictly speaking, you cancel this is dy dx. Dy dx equals 0 means there are 3 turning points here. So there are basically there are 3 turning points. Can you see? Okay. Over here, right? Don't think of tangent, think of the value. The value is positive or negative. Yeah. Value negative. Can see the value is negative. Value is positive. Value is positive. Even though it's going down, right? But the value is positive. The part after 4, Isaac, the value is positive or negative? Negative. Positive or negative? Positive. Positive, negative. Wrong. The value, don't think of the value of the, can you see I cancel out here, I put dy dx. The value of the dy dx is negative. The value of the dy dx is positive. Okay. -2, 4, 9. -2 minus. Anyway, this part, right, don't have to really care. So this 0, 0, 0. This is your x value. This is your dy dx. Okay, Isaac, tell me, on the left side of -2, the dy dx is, the value is positive or negative? Negative. Understand what I'm trying to do? After 0 is positive or negative? Yeah, after -2, sorry. Positive. After 4, Yingxuan, positive or negative? Negative. Go to 9. After that, positive or negative? Positive, right? Yeah. Okay. So then I know roughly the graph will look like this. Okay. The graph will look, so you see here, the dy dx is negative, right? Means it's going downwards. So it will go downwards. Whether it crosses or not, I also don't know. But you see, it has to be a minimum point. So basically, this one will give you a minimum point. This one will give you, because it's down, flat, up, flat, down. This one will give you a maximum point. You can see? Then the last part, this one will give you a down, flat, up. Maximum or minimum, Isaac? Down, flat, up. Minimum. So I know that the first one have to be a minimum point, right? Can you see this is the modulus graph? So do you think that this part should be above the axis or under the axis? Under, yes. Because you know that the gradient is negative, so I know that, oh, this guy, right, have to actually go under, and then after that, it will have to go up. And then after that, it will go under, and then after that, it will go up. This is the this is actually the original curve. How I know? Because I know that the first one is a minimum point. A minimum point cannot be on upstairs. It has to be below. So This one is negative 2 comma 5. This guy is 4 comma 2. This guy is 9 comma 4. And you will know how to draw the original curve. Yeah, still the negative, still the intersection. No lah, the intersections are still the intersection because this is the original graph with the modulus. So this is another technique. It's like if you are given the f prime x curve, right, convert it into a first derivative table. Yeah, then you will know how the shape look like already. Oh, sorry. Yeah. 9 comma negative 4, right? Yeah, and then this one should be negative 2 comma negative 5, right? Yeah, you have to draw proportionally. Yeah. Okay, understand? I will make this video anyway. All the lessons, all I cut into videos and put it up actually, if you all realized. Okay, so the important thing about f prime x curve to convert it back to fx curve, right, is to do what? Don't be fooled by, we are not looking at the tangent anymore. We're just looking at the value. But when it is fx to f prime x, right, we need to look at the tangents. The normal at this point, so when you see normal means you must find tangent first. How to find tangent? Y equals to x minus 1 square. Next step means dy dx equals to 2 bracket x minus 1 power 1 times 1. 2x minus 1. Okay, so that's the dy dx. At this point means you sub x equals to 2 my m tangent. So whenever you sub in a value, right, label this as m tangent. Is equals to 2 bracket 2 minus 1, which is equals to 2. So what is the m normal equals to, Isaac? Very good. So now I do y minus y1 equals to m bracket x minus x1 because the coordinate. So y minus 1 equals to negative half x plus 1. Y equals to negative half x plus 2. That's the equation of the normal. Okay. So the normal cuts the curve at the point Q. This is equation 1, y equals to x minus 1 square. Equation 2, x minus 1 square equals to negative half x plus 2. Don't have to solve, just use your GC and find. Okay, you can say from GC, Q equals to, the answer, what's the answer for Q? 9. 9/4. Basically, plot this as your y1, plot this as your y2. Use second function, calculate to find intercept, 5 intercept. Okay? Understand? Simple, O-level style. Okay? Use your GC to help you with very long level brain keys. Okay, so make sure your implicit differentiation is okay. The 2 can put on the outside. This is a product rule. Keep x differentiate y plus keep y differentiate x. Differentiate 2y square, Yingxuan become what? Well done, dy dx equal 0. Okay, so if you can make your dy dx nice, it's going to be dy dx equal, tell me what's your dy dx? Negative. Okay, if the tangent is parallel to the x-axis, means the tangent is this way. Right? If a okay, so this is your be careful, these are your things that is in the, so this is your y and this is your x. If your tangent is parallel to the x-axis, which means this way, Isaac, gradient is what? 0. So dy dx equal 0. So this means that negative x plus y equals to 0, y equals to x, equation 1, x squared minus 2xy plus 2y squared equals to 4, equation 2. Sub 1 into 2, you are going to have x square minus 2x square plus 2x squared equals to 4, x equals to 2 or negative 2. I think that's the answer. And then if sub back into equation 1, y will be 2 or negative 2. So you have 2 comma 2, negative 2 comma negative 2. Just like that. Isaac, did you get your dy dx correct? Still differentiating, I box you. Okay?
Wait, shouldn't it be x squared plus? Plus is negative 2x, then negative 2x, then y is negative.
Y is x though. Wait, you got bracket or not? No bracket, right? Okay, this one is a little bit hard.
Wait, that one is right. After you sub one in. I thought dy dx.
The question is not asking for stationary point. The question is asking for the coordinates of each point on the curve where the tangent is parallel to the x-axis. So when tangent is parallel to the x-axis means gradient 0, right? Gradient 0 means dy dx equals 0. I got an expression that's y equals to x. I want to find the coordinate on the curve. The curve, this is the curve. This is an expression. So I sub in the I know that when y is equals to x, then the curve, there will be 2 points on the curve such that it will be parallel to the x-axis. What are the 2 points that is on parallel to the x-axis? So I have to sub the expression into the curve, sub 1 into 2 to find what is the x coordinate and hence find what is the y coordinate. Don't overthink stuff. The question wants coordinate. The coordinate is satisfied by the curve. The curve is how the curve will look like. So maybe the curve looks like this. Then at this, so this is the whole curve. So at this point, there's a x comma y, but the y is equals to x. So basically the y coordinate and the x coordinate are the same. Understand or not? So I want to know where on the curve. So I have to sub the expression into the curve to find out what's my x values. Understand? Don't overthink stuff. Math is really just about problem solving. Okay? Can show that the normal at the point with the parameter t. So that means they give you t, x equals to 2 plus t, dx dt equals to, Yingxuan? Y equals to 1 minus t squared, dy dt equal, Yingxuan? So basically dy dx is equals to dy dt divided by dx dt, which gives me negative 2t. This is the, and when they say that the t is equals to t, you know, so basically the gradient of the tangent is equals to negative 2t. The gradient of the normal will be equals to 1 over 2t this way. Okay, yeah, so this is where H2 is a little bit harder. I have to find the answer. Y minus y1 equals to negative 1 over 2t of x minus x1. What is y1 here? Y minus 1 minus t squared, because they say that the t is t. Okay? Multiply the 2t to the left side is easier to do. 2t. Open up everything. That's the final answer already. Just open up everything and show. In fact, because it's a shown, right, you can just write, oh, therefore. So now they say, wow, a lot of information. The normal at the point t when t equals to 2. So you must put back to the normal. So the normal is x minus 2ty equals to 2t cubed minus t plus 2. Or when t is equals to 2, my x is equals to 2 plus 2, which is 4. My y is equals to 1 minus 2 square, which is negative 3. Cannot, sorry. Cannot have this. Yeah. When the t is equals to 2, because the x and y are like your variable. X minus 4y equals to 8 times 2, 16 minus 2 plus 2. So it's 4y equals to x minus 16. Okay, maybe I keep it as this. So this is now the normal. That's the curve again. Which one? Who is identified as the curve? So this is the normal, right? So you must know what are your things. My curve is x equals to 2 plus t. And y equals to 1 minus t squared. Can you see this is the curve? So do you want to find the point of intersection between the normal and the curve, right? Simultaneous equation. And then now they say that the x is t is equals to p. So now I sub 2 into 1. Oh, for what is the y? 1 minus, in this case, you can write p squared. And t is equals to p. Okay? Equals to x. 2 plus p minus 16. And I think you will get this. 4p squared plus p minus 18 equals to 0. Yeah, got nice number, don't have, right? P equals to 2 or? Huh? This one is, you don't need already because t equals to, that t equals to, you already used already. So p equals to, then now you sub it into the x. You are very weak in parametric, right or not? Because parametric use 3 different variables. So that's the solution for P. Okay, any part don't understand. So you must be very clear. What is the, you are using normal, you must use normal. When you're using curve, you must use curve. Write down cylinder, write down cone, and write down sphere. Okay, draw here, and then write down volume, and then write down surface area. Okay? Sean, volume of cylinder. Cannot be lah. Volume very simple, base area times height. Yeah, pi r square h. Okay? Surface area. Second page, sorry, second page. Yeah, second page, 8.0. There's a big blank over here. 2/3. No lah, I box you. 2 pi r h, that is the curved surface area, plus 2 pi r square. The 2 pi r square, this part is optional. Depends on whether you need or not. Janessa, volume of cone. 1/3 pi r square h. 1/3 pi r square h. Curved surface area of cone. Janessa. Pi r square, that's the bottom lah. If you need yeah. What is the cone surface area? Pi RL, well done. Pi RL. What is the meaning of L? Vanessa? Slant height. Slant height. Do you think they will give you this? H1 maybe lah. I'm not trying to tell you all to take H1. Maybe there are some other things you can take at H1, okay? If you feel you can handle math. Sphere, 4/3. And then a sphere is 2-dimensional or 3-dimensional, Ancient? 3, so r cube, okay? And then this is 4 pi r square. I teach you all how to remember the surface area of sphere, right? Differentiate, you differentiate volume. Differentiate 4/3 pi r cube, what do you get? Yeah. Differentiate volume, you get here. 4 pi r square. Oh. Okay. See, the guys, don't be distracted. Don't do a little bit, use your phone. Don't do a little bit, use your phone. You will never remember all this. Okay. How come I can remember all this? Last time my phone don't have color. Okay. Yeah. So now you go back to maxima, minima. Okay. A closed cylinder. Closed means what? Top and bottom also cover already. Okay. Has this has a and you know why they tell you this or not? You know why they tell you this? Write down. This guy is the info. Write down. This guy is the info. The info is always to make the subject. Okay. The info that's given to you, right, is always used to make the subject. Can? That's Mr. Ivan really very nice right down there. The volume is equal to 0.01 units cube, right? To remove the H. So because you see, I have write down, have R means I need to remove H. Means H is the subject. You want to use H as the subject. So volume of cone, pi R square H is equals to 0.01. H equals to 0.01 over pi R square. Understand? Info is always used to make the subject. The one that you want to remove always make the subject. Okay? So now I can say that this is equation 1. And S is equals to 2 pi R square plus 2 pi RH. Tomorrow we teach this to the boys. Okay? Huh? Yeah. Which is, I want the R. 2 pi R square plus 2 pi R. What is the H? 0.01 over pi R square. Oh, so this is the S. So this is the S. 2 pi R square plus. So now 2 times 0.01. What do you get? 1 over 50 long. It's 0.02 lah, right? 0.02 minus 1 over 50. You don't always give back to what the question wants. Cancel, the R cancel, or over R. So that's why the R is at the bottom. Okay? Standard one. After you get this step, Shen, what is the next step you do?
Is it differentiate?
Always differentiate. Now, can you see that the R is below? Don't bring the 50 up. Like secondary school like that. You always want to go and bring the 50 up. Don't bring the 50 up. Okay? This guy is also same as S is equals to 2 pi R square plus 1 over 50 R to the power of -1. Only bring the R up. Don't bring the 50 up. You bring the 50 up, you are going to get into trouble. Then the next step standard, ds over dr equals to differentiate 4 pi R minus 1 over 50 R power -2. Or power bring down, the -1 bring down, power decrease by 1. And now you make it back. 4 pi R minus 1 over 50 R square. Okay? Next step. For stationary value or for stationary point, ds over dr, Josh, equals to 0. Okay, yeah. Then this kind always is you write down this minus 1 over 50 R square equals 0. Bring the negative guy over. 4 pi R equals to 1 over 50 R square, like that. Okay, cross multiply 200. Say again. 200 pi R cube equals to 1. R cube equals to 1 over 200 pi. You see, own self cross multiply, make it linear first. Make R the subject, divide down. If you can own self Or for Janessa, like R cube, you can go up, 4 pi can come down immediately, that's fine. Okay? So what is R equals to? You are expected to leave it as a exact form, 1 over 200 pi with a cube root on the outside. Leave it in the exact form. Okay? Did the question ask you to show that it's minimum? Never. But they say that it's minimum. You must own self go and do your second derivative test. d2s over dr square equal, differentiate this, 4 pi. Negative 2 bring down, plus 2 over 50 r power negative 3. This is 4 pi plus 1 over 25 r square, which will have r cube, which will always be positive when, you must say when r, because your r is positive. This is how exactly you write the working. So if the second derivative is greater than 0, Isaac, maximum point or minimum point? So therefore, did they ask you to find the minimum? They ask you to find the value of R for which S is. Sometimes they will ask you to find the minimum value of S. Okay, therefore S is minimum when R equals to cube root of 1 over 200 pi units. Standard question.